नमस्कार, गुड मॉर्निंग, सत श्री अकाल, अस्सलाम वालेकुम रहमतुल्लाहि व बरकातहू, वणक्कम, namaskaram. This is Suraj Singh speaking from Bharat, India, located in NCR, Faridabad, July 29, 2020, and talk as usual regarding regarding engineering management and management engineering both. What is engineering management and what is engineering and management? Both are here. Both are important, materials are important, soil is important, and contracts are important, designs are important, work execution is important, and what is not important? There is nothing as such which is not important. Everything is important in field of construction engineering, design engineering, and production engineering, and you can say life, generality of life, safety in life, quality in life, planning in life, expectation, miraculous work in life, everything, all that is in engineering is in life, which is very important from each and every point of view to understand in life. Always, you know, we say that as usual, this ordinary paper I show to you indicating my simple nature and simple nature of world. That should be as he shows. We should not forget our past. We should remember that because that made our present. Past makes our present, and present makes our future. There is no miraculous work that is done for future until you get some lottery or you are born in some very rich family where by inherited you get something and not by your hard work. So we should not forget our past and we should remember that, and followed by present modernity, we should combine both and understand what is life. Past cannot be discarded and present is adopted, while future has to come in, which everybody doesn't know. But there is no miraculous miracle in this world that says you will get this one by virtue of your luck. Well, I don't believe in that. What we get is because of work and not because of luck. And those who think that by luck they will get automatically, I think they should learn from nature, learn from God, and learn from history. Yeah, sometimes you get it by chance. That is, that's not doesn't mean that's your right. Means you cannot claim that's your right. Nothing is your right. It's by chance you get something. It doesn't mean that's yours. Sometimes it happens that you get something by luck, and you think that that's happened for you. It's not that. Luck is just luck. It's nothing else. So we say, my God, I'm not able to see my finger here. As usual, we move over. COVID, very dangerous now. And we say God actor virus, we don't know. But engineering we know because we studied that. Engineering management and what every day I show you organization and challenges, and I can say human thinking, which is last resort, only resort, no other resort, general concrete specifications, systems, quality structure, and soil engineering, and FIDIC, so etc. etc. All we have to, whatever time permits, we have to see what we can talk of in this short time of 3 to 4 hours or more. It may take many hours to complete all this, and that's not possible because it's not both for you and for me. There is a limit for timing as well. So, but description of subjects are very important. We should We should understand each and everything in life, and that's very important. I can say, and life moves on and on, but we have to keep up with life. That's more important. We should not stop in point. We should continue journey, further journey, whatever journey we got, we should continue until we leave this airport or railway station or solid station. You may call it solid station or life station or whatever station we call it. It keeps on moving, moving and moving and moving. I, for information, just so that I put I put here on this. You know, I have put the URL of one. You know, screen share, screen share on Facebook. One file which is related to thermal resistivities of soil and also electrical relations. With that, this file is given in just top of text, and also you'll find this there. This file is related to soil, which I'll explain to you about 29 pages on this. URL videos there, not in title. When you go next to title, first line after date on text is title repeat, and after that title repeat there is one screen share title URL, and URL and title both are there. Screen share, which is for that file which I cannot pull in into live video because I think system doesn't work. Facebook doesn't work that way. I wrote to them also that I can't follow up later on when I finish sharing a file, screen share a file. I can't continue with video. But there's some subsystem problem, and I have not received any response from Facebook till now. I think maybe they are not clear. They just sometimes write that online you can work, but they have not tried that. And particularly, I didn't find any video as such by public too. But I tried this just to put in file there. Well, there's a separate video for that. It's called screen share. And just put in the explanation I could not make on that share. But it takes time, and I'll make in this. Yesterday I participated on that file. I used that for your information. Let me see how it works today. But before that, we talk generally about COVID information. It's not a detailed talk on COVID just for 1 or 2 minutes. It's spreading again and again, and it's now many European countries are worried that it's spread coming back to them. They are calling these waves. I won't accept that waves or no waves, but this is not that's not gone, and it's actually rising. It's progressing all over the world. It's progressing in a way that nobody knows what's its speed or doesn't know. It's full-fledged, powerful now, and in our country, Bharat, India, our reports say about 50,000 cases a day of infections are reported. But I think it's just official figure. Otherwise, it may be more than 200,000 per day. That's fact of life. We should not deny we are a big population, 1.3 billion people. And just I got a report 57% people are affected in slums, and about fewer lesser than you may say about 15 to 20% people are affected in residential colonies. And slums are much worse places, and they are saying 57% people living in slums are affected. You should not forget major cities like Mumbai, like Delhi, and like Calcutta, like somewhere else you'll find lot of slums everywhere. This means dangerous city on our head, danger of infection. I'm not worried about death due to those cases, those infections. So that means you are relieved of your life. But the question comes to the infections means once you are infected, it's the start of deteriorating your health in future if you don't take your care forever. Deterioration of health, detrimental effect on your body by that impact of infection means You are now back from hospital or from isolation. They say you're released and you are back. Recovery, first of all, I don't accept is that this is recovery because you don't know what actually happened. Recovery means you should know what illness is, what sickness is, what disease is, and what's true solution. True, you can say solution of that disease, treatment is in medical words. It's treatment or treatment of disease. When you don't know by just knowing few symptoms of that, and you decide that this is COVID-19 or corona, and then you treat. You are having no treatment first of all. That's one negative point. And secondly, nobody is expected to accept some vaccinations, which won't be in fact treatment, but some immunity plus, you can say. Those may help you if these are successful to raise your immunities. Otherwise, those vaccinations got no meaning because we don't know what's truth behind this, what's the root of this disease, and until we know that, we can't say anything. This is my normal understanding. I'm not doctor. I'm from engineering field, so treatment is not my profession, and pathology is not my profession. But I'm just advising from my common understanding that people in world, some people are interested only in making business because of corona, while there are very little people, very few people who want to serve humanity. And when scientists, thousands of scientists around but could not understand origin of this, origin I mean is not from where it started, but how it works, how it generates, if it's living being discovered or it's not living being, that's also not known till now. They say it's living being. Might talk to one doctor say no, it's living being. When it's living being, this means we cannot make some living being first of all. This means then relation to laboratory production of bioweapon doesn't stand good here. So we have to be very clear in our mind that if it's natural or it's God sent, then this is warning to whole world. There's a message to whole world, and that message is by exhibition, by demonstration. That I am sitting here. Don't forget me, and I will not leave you. Or my children have every right to teach you certain lesson. That's main message. You have spoiled my work, you have spoiled my earth, you have done everything. Times and again, I suggest to people change your habits. Don't think of economy only all time. Think of your existence. Think of what losses you have made to earth to fulfill them, refill them. And you can't do that because you don't have that capacity. But at least you can do as little as you can. That's very important point. So I will not go much on COVID because you all know all news here. News is important. News are statistical news. Means still people, still scientists haven't cleared what we are, how we are getting this. So until we get, I don't think we shall get real root of that. So COVID will stay there or may not stay there, but effects will be here. So you must raise your immunity. 90 or 80% people don't have immunity body, healthy body. They are living in artificial style. Then they are not cooking food. For example, now British Prime Minister says don't consume fast food or what is called junk food. Now they have known after all their lives have gone, all they have become obvious, obviously have got whole Arab world, whole Gulf countries are of this. That means 40% sheikhs are having overweight. Similarly, I think 40 to 50% English people are having overweight, and same applies to European people and to Americans, and also to our people who are in higher money ankle on with so-called money VVIPs. I would not call them VVIPs because they have no character, no quality, or no eligibility to be called VVIP, but money VVIP, money people, rich people. So we have to change our habits. We have to come back to some natural environment like we should in past, cooking at home, try to do everything at home, avoiding market products for consumption, and have little down life rather than having all luxurious in life. All this we have to do actually. We have to come back to agricultural level where you are living simple but high thinking. You are living simple, but you are producing something that everybody can take. You are giving life to people to eat. That's why we say they call andata to farmers. Andata means one who don't gives you one who gives you food. Like that powerful person is called farmer andata, and that level we should get. If I am an engineer, it's my duty to help society in the best way I can, in economic way I can, in best use of metal, optimum use of metal I can. That's my duty. It's not my duty to get better job, big job, and say hand getting this package. As all other educated people say that we want this package, we want MBA degree, or we want some other high-profile syllabus or program, and then we want this and that. Means ultimately they are destined to their calculations are destined to their objectives are destined to one point, and that is package. Education is being measured for against package, which is actually root of evil, you can say. You are only interested in make money making, and that's why you are going to university for education. You are not going to add to development, add to good society, add to good earth. You are now better earth, you can say. You are not going to serve humanity. You are not going to reach the standards of your mind to make intensive thinking. That's not objective. Your objective is very low profile, that you just want a package. And when this kind of scale comes in, then my education should be that I should get that much salary. And when that picture comes in, same thing as some businessman says, oh, I should get this much profit only, then I want this job. So if everybody is behind profit, then I expect this COVID like situation, because ultimately you want yourself self benefit. You don't want benefit of society as whole or world as a whole. But God is in charge of all. But God is not. God never considered that it's of this country or that country. Whatever religion you follow, every religion says this power is for whole world. If you say Krishna, what Krishna says, what Ram says, what Jesus says, what Muhammad Sahib says, and what all others says, they never talk of one society or one group or one nation. They talk of all humanity. Guru Nanak Sahib says same thing. All books say same thing. It's only we foolish people of world which always count on religions and caste. This is our weakness, because we have artificialized something which is not concrete, just got no meaning. But we are following that, and that's where problem lies. We should understand that there is no formal proof that there exists some religion. It's all your option. It's all imagination. It's not, I'm not talking against any religion or faith, but fact remains that nature, we know, it's evidence that God exists. It's direct evidence. It doesn't tell which form it is, which religion is it. It's we follow someone. God doesn't follow that. God never claims I this is my religion, because God doesn't believe in religion. God sent me as human, not as religion. This point also clear. We have to change our mindset. We have to change our economical standards. We are not to go behind economy all time. We have to first of all think for people, safety, people's welfare of poor, at least, if not all. It's important for everybody. The poor are there really penalized by God, but that doesn't mean they should be penalized on earth. They should be supported so they can pass. You are rich, okay, you can enjoy your life, but don't forget there is poor also. Because of him you are rich, otherwise you won't be rich. If you don't have workers, now what's happening? You see, thousands of jobs are there, thousands of projects are there without workers. Have you heard that? Thousands of jobs, with more than 10,000 or more. That's somewhere in Bombay itself, and many other cities are there. You see, many thousands of jobs or projects are there which are not having backup, which are not having workforce to work for them, and those people cannot. This means that is very important factor. So resources, workers. If workers are not there, in that case, you cannot do anything. It's not only for projects, it's for factories, it's for industries, it's for all sectors of life, that you're not doing anything yourself. You are using others. That's why you're becoming queen. You're being, well, this for whole world. It's not only for our country. If there are no resources, there's no human, there's no worker, you can't work. This means human is equally responsible for all, and worker is most responsible, above all responsible to make your riches. You are not riches because of your own. You are riches because you are using resources. Yes, you can buy machine, you can buy material, you can hire people, but people should be willing to work. It's that positivity that they force them to work. Of course, they get some money, they get salaries, they get their lives, but they are not your slaves. Point is that they are not your slaves. They are also, they came from same home you came from, same person, same father sent them to you to this earth like Tuesday. You came to some richest person, or by your luck you got some money and you have become industrialist or you become promoter or someone. It's because of that. This point we have to understand to change society, and changing society means changing everything. Engineer has to think about that because engineer is supposed to be social changer. Engineer is supposed to be change agent, representative change. Engineer is supposed to be a leader of society, leader of profession. Leader doesn't mean political leader alone. I don't consider any political leader currently leader involved because there is no such leader who could lead this world in this current super critical time of COVID-19. All leaders have failed, but public is still digesting everything. Public is confused, of course, but public is tolerating everything. The public is tolerating nonsense of leaders. Many leaders in world still know they work nonsense during this COVID period. And actually, many, you can say, including our country, USA, England, and German, and Europe, and China, and many others who acted foolishly, all top leaders. And this is means they don't know anything, to be very frank. I suggest even they are politics, we should have educated people who understand something, who understand what's expert, what's scientists, and then they should work. Our people are like fools, and I reject them all, including US President. Well, it's not that talk I should make, but just I'm expressing my anger because I'm talking of something which is related to whole world. And whole world has suffered. He says suffering and shall be suffering. We can't stop it, but we can think on. Job of engineering professionals to think, job of every professional to think. Unfortunately, in this country, Bharat, there are millions of professionals from various fields, but they're all futile in thinking. I don't know what's the reason behind that, what threat they have, what cowardice they have, why they are so afraid to speak or try. Only maybe hardly very few people write something. It's your duty to write. It's your country. Leaders not for this country, your country. You are responsible for this country, not prime minister or president, someone else. They are only our representatives, our servants. It's our country, my country, your country. We have to be responsible. And this is for everyone in whole world. This is your Americans also can say it's their country. Same way British can say it's their country. It is their country means that's their country where they are living in. It's uniform principle. So we have to take care of world, or you can say for every citizen of world, whole world is country. And in fact, that's a fact, but that because of political reasons, geographical reasons, we are not using that for your formula. But God wanted that. God did not mention any you are going to finish do this and that. So God wants something, God desires something. We did not fulfill that desire for millennium years and centuries. And there is always such type of impact on society, on humanity, whenever maybe in century or maybe in millennium where maybe I don't know past history, but could happen. And there is in stories or in fictions or in epics, I don't know, but there is always something. Well, it's now physical, it's now, it's evident we are watching this, you have experienced this kind of, and maybe after 200 years, 100 years, people may not know, may not remember what COVID was. But fact is, it is, now we can see, we are witnessing that. Is we should learn from what God intends to say. God says, change yourself. That's it. So simple. First is don't be dishonest. So me, I should be dishonest. 95% people are dishonest. That's where the problem lies. Dishonesty doesn't pay. Non-sincerity doesn't pay. You have to change your style. You have to think for nation, not for your family alone. You have to think not for yourself but for everybody. Wealth is for all, not for you alone. Yes, you can accumulate wealth by snatching from others, by abusing other people. Remember, nothing is permanent in this world. Today you are there, tomorrow you will may not be there. Today I'm talking to you, tomorrow it may be I was there in this world. People may say that person has gone, and they simply say RIP, and that's all, nothing else. So I'm not doing for RIP, I'm not doing for something. I'm just doing what I think is my duty to do. and that's I'm doing you everything. Something comes into my mind and do it, because not because I want some money. I want some credit on that. That credit I don't seek. Money I don't seek. I don't seek any appreciation as well. Yet I keep on moving because God forces me. God gives me energy. God gives me will. God's give me what direction I get. So I move. So you move. So everybody moves. Why wait? Why wait? Tell me. There's nothing to wait. You have to tolerate everything. Sometimes we make mistakes and we get problems. That's what we do. So, well, it's not criticism at all about anybody, but I'm just saying that engineering is something which is for everybody. Engineering is not for engineers. Engineers are just leaders in that, the servers in that. Engineering is for everybody. Everybody is related to engineering directly or indirectly, this way or that way. If you don't relate to engineering, it's not possible. I don't believe that everybody relates to engineering and we do engineering this way or that way. Even if you do something in your home, you are applying something there. That's also engineering. You may not understand that sometimes very small work also comes from engineering. So engineering is not actually what you learn from university. Engineering was your experience in life. That's very important point. What is your experience in life? A lot portion of that could be engineering. You don't understand. You use engineering every time, but you don't understand. You use it all time. You don't understand that. Unknowingly or sometimes by error, we do that by our habits. We do that. So many you know activities are there in our lives which we do every day, and that makes our integral system further strengthen, and it strengthens means our activities do that. We get up in morning and we do all day our routine. Everybody does that, and that's where you have to live. You have to do that. That's called your system, your design system, or you may change that. In that system nobody can force you. You do daily, and if you do not do daily, you change every day, you will find yourself in some kind of irritation type. Means you don't develop any system and you are not following any system. You become a systemless person, and systemless person doesn't mean anything. Means those who don't organize anything, they live. I don't say they don't live, but that living is in uncertain. You plan something, you think I should do this, and you can do that. Means you have no difficulty in that. You have required resources with you, time with you, but you say, no, no, I go to sleep better. That's the point. You go to sleep for what? You go to sleep. Okay, you go to sleep. Then you lose time. You have violated your own system. A person, I consider an engineer or a professional who organizes self, approves self, devises a system, and follows that. And whenever required, adds changes to that and then continues on that as operation. Never stops and continues like that. That person is called organized one. Organized one. Maybe small organization from morning till evening, but organization is organization. So your body adopts that system. That's also a fact. Maybe one day you sleep, I got up morning at 3 o'clock, 4 o'clock, you decide that, or 5 o'clock. You decide that. Maybe one day you need time clock alarm or your something else alert. You don't get it, or you get it. You you don't awake at that time because you are not used. Okay, one day you don't do. And when you open, you say, "Oh, I'm late by 1 hour." You will dream something. Next time you'll get up actually, and it happens twice or thrice, then you naturally don't you won't need even alert or that it get up because your mind accepts that time, and your mind will force you because your mind is reading. Maybe you are not reading. Your mind is awake. Your mind rising. Your mind does not sleep. So that energy in your mind, which is automatic, You may not understand that, but that energy works all time. That energy shall awaken you, and you get it. This happens. This programs. This automatic. Not only this, you program everything every day. When you think, oh, it's now 1 o'clock, you feel hungry because you are used to that. 1 to 2 maybe, or whatever time you take your lunch, your stomach says, now it's time, I should take lunch or my dinner. You do that. Why is that? It's nothing but your body's organization. I am talking about organization here, part of management and part of, you can say, part of reality of life, system in life. Management or organization, nothing to systemize your activities, to systemize various of you many of your activities. Otherwise you cannot have anything done. You cannot schedule out anything. When you say schedule out this, that this system as it is, whatever system you follow, you reach an end product. It depends upon your system, how workable, how adaptable, how good your system is. You devise that. That's where we say something is rich. Say, I'm talking that system. I'm talking that organization in engineering. Engineering itself is full of system. No engineering is free of systems. Engineering means system itself. Otherwise, you cannot engineer anything. You have to devise something using your mind, your project, your plan, your designs, whatever is with you, wherever you're working. You have to devise system for every activity, for every group of activities, for every disciplines of activity, all disciplines, and ultimately you can say all disciplines work for one project, or that's called project, and you can do that project. Otherwise, if you don't have any schedule of that, your schedule is scheduleless. In that case, no one can assure you you'll get something. You cannot predict any, you cannot forecast any date for that closure of project. And if closure is unknown, in that case, you can say that you cannot get. Somebody asks you when you get this, when you've done this, you shall do this. You would simply say, I don't know. If you say, I don't know, this means you're not organizing anything. You do not know means it will take 1 year or 6 months or 2 years or 3, or when you do this, you don't know. This means you are not person with system. You're no system at all. Now everything is systemized. I am talking on computer. Computer is a system. Software is a system. Hardware is a system. We travel daily using car. Car is a system. System design, where every part works in same direction to get same use of product. That product or delivery of products for that product, and that should still functional. And profession means it should work for what it was intended to work. That's why I'm saying management in engineering is very different. This is overall management, because this depends upon your success in achieving results. There are some systems of management, there's no result, nothing, just continuation of activities. That's not profession, because there's no accountability. Okay, you're working, that's it. You're getting salary, you're doing job, but there is no accountability, no obligation, no responsibility. But in engineering, everything is there, and that's where the difference lies. Profession with a difference. You can say engineering profession, a different profession. It's a responsibility bound profession. It's obligation oriented profession. It declares you are sincere, you're committed, you are ambitious. Ambition doesn't mean personal ambition. Ambition means to reach your requirement, to give your results means what you thought, and those results should be per planning, or per requirement of client, or whatsoever it is, must be with that. And that's where I say engineering lies means. Engineering doesn't mean design or working alone. It means everything. Whatever you do, whether in design or in construction or wherever in life, in whatever discipline, whatever branch of engineering, it should be professionally oriented. Professionally oriented means it should be according to requirements, and maybe at least meet requirements. If you are not super, not value added, it's better it's value added. But in case it's not possible, then put your way at par with requirement. It should meet requirement. If not, move on. So that's where profession lies in. I I think about question all days, every time, and I find something new every day. I think every day about that, and not now alone. I've been thinking for long, and I find there's a difference. I every day find what's difference in this day if you compare to last day or days, or what I expect tomorrow happen because of today's. I can simply say I can understand what's next day coming in, and that's where you can say immediate vision or long vision. uh, there's long vision, short vision in engineering, and engineers have to do that. We can learn from first. If we have some lessons, we made mistakes in past, and we understood, we learned that from the mistakes, and if we don't improve our acts in current or in present working, this means we don't learn anything. Engineering is a teacher. Engineering is a thinker. Engineering means thought. Engineering means what? Teacher. Teacher means teacher doesn't mean class teacher. Teacher means learning. Engineering profession is based on learning. Look, they are both. Engineering is based on learning, academic learning and theoretical learning or tutorial learning, experience learning, whatever you can say there. Engineering is based on learning, and you have to learn from engineering. Both are there. Engineering is a profession of collective learning. It's a profession of collective research. It's a profession where industry moves to college. Industry moves to student, and student learns. But this movement takes time. It doesn't mean something happens in university today, you shall get tomorrow in university. No, I'm sorry, what happens in field today or in factories or somewhere else in practical field it happens. It doesn't mean tomorrow you will do that in your university institution. It takes long time because very slow process, and books and all that. It's not easy. So profession of engineering in academics is labs everywhere. It labs, and there's so much development in professional field of applications, and that must come to office of engineering and office of education of engineering, and until that come, you can't say that you are called obsolete because your knowledge is obsolete. It's not updated one. And when knowledge is obsolete means you are talking about absolute knowledge to your employers who would be employers. So they're not happy with you because you're not suited to that job. In that case, you have to learn on job or somewhere else to at least be fit into that system. That's why I say engineering is not present one. Engineering means past plus present plus what is expected in future. That's all engineering. Engineer is always a visionary. Engineer means you have to think for long. If I want to design a building, it doesn't mean I will think of today only or I will think of past only. I should think of past, I should think of present, and I should think of future. This past plus present plus future equal to my contemplation about design, about my concept, about my, you may say, what I think about my vision is how I means my mind should be active for all these three. Past doesn't 100 years past. Past means past works, past activities, which I did or you do or similar to. We have done. I know where I did wrong. May not tell anybody else because it's not required. But we know there was an error, and of course we hide that error. That's not professional way. We should declare that it is an error. That's professional requirement because if you made mistake, you caused a mistake. Everybody can cause a mistake. Causing mistake is no crime because you worked. Maybe that something wrong was in design, maybe something wrong was somewhere else, so mistake happened. Real fact would come only after investigation is completed. But till then, we have to learn is I know what was there, I know what happened, but I'm not sure. I say possibility is, but we know errors. We know errors happen. It happens in designs, it happens in bugs. Now, designs errors are removed because of software, Start Pro or ETAB, whatever is there. These are fast designing tools, means we can design very fast in this. But problem is not designing, problem is how to design, what to design. Today, collapse is that those engineers who only rely on software, they do very fast indeed, but maybe they do not know any formula. I'm not talking of those senior engineers who have worked in their field without software. They may know every formula because they practice that long. And I'm also one of them. But I'm not boasting that one because I'm not good at software till now. I did not even apply software, Stat Pro or either. Yes, I would just watch you on some YouTube or else what is that is. I think that it's no application or use of software is not a big deal because it's not your design, it's application by someone else, and that person who input formula on worksheet or something else and connect it. They're is closed architecture of software, not open architecture. But you can also accustom. It takes time. I tried to do Carney's theorem, Carney's rotation contribution method for analysis of designs, and it took me time for a long time. But I still apply that whenever I find some designs of frame analysis, RCC buildings. I do that successfully, but I could not expand that because I'm single person, don't have time for that, and it takes concentration, requires time to do that. But there are so many other ways wins. We use start province. It's so fast as if nothing is there, but it doesn't mean that. It's your thing. Yes, you are. It's solving itself. When you say run analysis and run design, it runs, but you have to model it. And modeling is also not very difficult. Its coordinates are automatic. You're not giving anything. It's not very big deal to work on software. If you're experienced one, I'm not that expert. I'm just trying to learn elementary. I've done a software. It's expensive, right? And well, it's not my talk here for software, but I just as part of my like, software has made our engineers, little less calculative. Calculations become weak point, and writing has become weak because of communication by computers. Writing power has gone, and you can say writing power has gone, and also calculation power has gone. And remember, this writing power and calculation power is actually root of your development, personal development. If I cannot write, I have to use computers, words, or some other only. This means I cannot think. Also, if you remember, if you practice writing, your mind works and intensifies. It concentrates on that. So mind not only writes, it also concentrates. So writing generates concentration, and writing generates little thought, and it goes back in its past. When you learn something or you wrote something or did something. So writing practice is beneficial from many aspects, but people are not. I've not seen much writing these days. Similarly, is writing and also your calculation issue. When you design yourself from first principle or something, you have to calculate everything. You have to calculate a thing and then assess the results. This doesn't happen in software. Doesn't mean we should not use software. Software is very much reliable. It's very fast, but we should not run away from calculations also. That's what I mean. We have to do both. We should not condemn this and accept that. That's not real world. We have to do it. So as an engineer, I respect professional development. I respect update, and I think I have been learning only from updates. To be very frank, there was nothing to learn anymore when I was engineering student. Means you learn according to that time, and every now there's computer syllabus. So much is there in syllabus is changed, and that time there was no computers, so there could be no meaning of software studies or systems studies. And changing syllabus always changes. Engineering means the update, and of course it affects examinations, it affects syllabus. When I was doing my engineering degree from an issue on the India, uh, that time there was different of schemes, changes of schemes. One was called old scheme, other was called new schemes. So I had to damage them to new scheme. There are nine subjects in section A and eight subjects in section B. As in previous one, there were less subjects, and of course, it time changes, engineering changes. Engineering moves with current times and expected future times. Engineering doesn't move backwards. Means backward is there, history is there. There was the stone construction, brick construction, and before that, so many other construction. They nowadays they will not find stone construction except for some decorative work or some work where stone is cheaply available, like hill station buildings or somewhere. Otherwise, there is nothing as such. Changes are changes and must be. You cannot avoid change. If you avoid change, you remain behind. You can't move with this system. You can't move with updates. And I'm not saying updates are extraordinary. Updates are there. Systems change, and still formula are same. You can't accept some empirical changes, maybe there, but formula that are derivable, which are derived, means they remain same. Still bending moments, shear force, movement, have all we consider in our calculations or designs and analysis means are still same. There's no change. Still, you cannot say this formula is just now new one. No, it's never new one. Yes, units change, and notations can change, but systems remains there. Systems remain there. My dear friend, I always talk something before going into detailed tax of technology, just what we understand. Because engineering management is so vast, you cannot just conclude that or explain that in small time of 20, 25 minutes or 30 minutes or 1 hour. This is based on no book knowledge. This is everybody has different experience. I am talking this. There are many senior to me, veteran to me, who have much more experience than me. If you talk to them, they make explain to you much better than I'm explaining. It depends on individual interest. And engineers are, of course, very brilliant, extremely brilliant people, irrespective of age, I can say. If you talk to them and they want to talk to you, you'll get lot information from them, unlimited information from them. And I'm sure that is because maybe they are not serious, or maybe they have no interest in life due to many reasons. Everybody has some problems in life, family reasons, some of the reasons are no work reason or age factors, but but their minds, we have to think American way. You see, what America thinks, you are senior, you are older, you are better than young because you are old. Once I was sitting in Qatar and many Americans were there with me, armed forces, construction manager, and his consultants, and all the Americans or American oriented citizens from Philippines or somewhere else. And they were arguing based on who is this, what's your age, and what's their age. I was just listening to them and say, I said, oh, I am oldest one. I said, no, no, I'm older to you. Oh, no, I am most old here. Means being old is respect in USA, and it's reverse respect in Bharat, India. Oh, this is old man, Satya Gaya, 60s, bloody hell. Why are you interfering this? Yeah? This is standard of thinking. Our youth think that, your age, say you are young, you're old man. Why you go as home, sleep, don't talk like this. You must feel some degree of shame. You're interfering like this. This is our standard. Their standard is they respect seniors, old veterans. Oh, you are old, I means they respect that. At least we say culture is they are naked one, they are bad one, but I think they are better than us. Thinking is different. Level of thinking are different. Means you after you really are you are will get lost, you're retired, you use. There is a difference. Means they value humans' age, humans' experience. Here young think I'm everything. I was also young. I never thought that. I never think. Yes, you have different personality because you have not seen life, and whatever you get, you think you have everything. When I passed my diploma, I have diploma and all diploma. You think you passed degree. I am BE and this and that. And we used to argue in our office and that was in government service. That I was not degree that time. I was just studying, and many graduates from the institutions or regional colleges. Okay, we used to argue means let's talk about engineering only. What argument is? We are not studying about. We are not talking about girlfriends, boyfriends, cinemas. So that means engineers don't talk like much. So I used to ask, okay, I'm not yet. You are graduating. You're claiming. Tell me so. How is this? So because they start, that age is for debating. That age is something else. You are sitting free in lunchtime or just half an hour, and you're talking, interacting with us. You what can talk? You talk like that. Or they're talking some films or cinemas. They are not interested in. So, but I don't mind. I don't blame that because young are young. When you are in your society, you are different. You have that approach only. But you have said you are interacting with different ages, and you should respect. Now that character is missing in our society, Bharat, India. I don't know reason behind that, but it due to political reason or due to some other reason or unemployment or something, there is something which is means it doesn't support that. Otherwise, experience is experience. If there's no, why do you respect your parent? Can you speak same thing to them? Can you abuse? Say, oh, you're my boss. I should say, I shouldn't say that because I can't say that. But they write that. Forget saying they write that. And so, really, first time I feel in my life when since I started using this social websites, social forums, or Facebook or something else, that people having different thinking. Youth have changed actually. I cannot say all youth. I can say some youth who may not be very well educated or you are misled by political parties. Maybe that could be a reason. Otherwise, they should not worry about political parties. They are youth and future of country. They are future of this country. They should think for nation, not for political parties. But it's not happening. It doesn't matter. They will learn later on. It happens that when you are young, you have one basis, you make some basis, and you don't change the basis until you find a better base, to be very frank. So it happens. So management in engineering, that's what I always say. All this I consider different because we deal with workers, we deal with staff, we deal with human relations. So we have to see all ages of people, all ages of workers and staff in our professional time. We get that and we learn from that as well. Every engineer has to learn from resources. You may have 500 persons working for you, 100 persons working for you, and it's your duty to know as much as you can know about them. Not in person or in through someone, or also in person if possible, because it's your duty to get one team out of people available. You must have some integral team with you that can support you, and until you have that integral, this is a human resources management, to be very frank. This is management, to have knowledge about your people. Somebody comes to me, joins my team, and it's my duty to discover. It's my duty to discover secrets of that person, not personal secrets. I'm not saying that. Working secrets, cultured secrets, what that person is, what that person thinks, and what that person destines for. That is my duty as an engineer for my support to think of, to decide about. It cannot take one day, it may take months to gather and depends on performance, commitment, sincerity, and many other factors. So this is job of engineering to find your team. Doesn't mean that that team is only for you. Means you have to use them for project, even it is for 1 year project or 2 year project. You should get good people move in unison, who move with harmony for positive working, for you can say affirmative working on instructions, on information provided. That's very much part of engineering management. How to how to bring up yourself and how to know about your people on job. And once you know about them, maybe on this project you may not get that much benefit, but you should know that You should make files for everyone. That is possible. Not I saw this means on sites. Some people maintain files for everybody, particularly for staff, and the staff maintain for the workers, relative crews. So we know, first of all, we know background of that person. I miss ones who use files of individual personal key personal staff or your workers. You have a CV, of course, maybe in brief, but you have a CV of that person. You have a background of that person. It doesn't mean you think of his religion, that person's religion or caste. It's not my headache to know religion or caste. My headache is to know character of that person, capability of that person's, skills of that person, and of course academics of that person. And that and based on this information, I can utilize that person where I think that person is fit, or where that person claims that that person can perform better in that position, and that I can only by directly talking to that person or through my other staff to talk to that person, where that person can be better suited or placed, and that's where we can say this is your placement style, placement formula. Right person should be placed for right job. That's best policy, that's best principle. Because if right person is there, you will have confidence in that person. That person would think, yes, I'm getting my respect, I'm getting the job, I know this job. That person may lead you and lead others, because that person is expert of or skilled person. That person is skilled one, will help you comfortably without any problem. And at the same time, you can ask him to learn more skills for making better future. If not use there, if you join some other job, it would be useful there. I should not mind my people saying, I'm not happy here, I want some other job. And if I think people is good for it, I try that person, continue in that. And if no, I am not happy with this company, that okay, fine. I'm also not this happy with you, I'm not sad with you. Okay, it's your right to join job according to your wishes, but learn, and there's no limit to learning, particularly field work, because they don't have to learn technologies in writing, or they don't learn skills in writing. They have to learn that when they do that or they see that being done. Both ways are there. Both are important functionaries, both are important systems that you learn from existing system, and you learn more and understand technologies. Our engineering is nothing but group of technology. Every site, every other work, or even designs are group of technologies. These technologies are our technologies, I mean to say, when we use them for our jobs, that's where we can make something. So engineering management is very different. Means you have to involve yourself to learn more and more and more and more. You can see there's no limit. Interdisciplinary learning, discipline learning, specialization learning, learning something others don't know, and learning for your benefit, learning for your future making, and learning and learning and learning. And once you are habitual of learning, then there is unlimited scope in your field. You can do a lot in your field. You can go to whatever extents you want to go. Nobody can stop you. But it depends on your interest. Your interest. Yeah. That's only reason that I want to share my whatever small experience I have, because experience is also education. If somebody does not know this point, what is experience, I would simply say consider it as education. Experience is real education. It may be design, it may be field physical work, or it may be coordination, or it may be whatever your role in your job. Because you have academic background, that background is solid support, a concrete support. That on that you stand, that is hard standing fact, or you can say that's comfort studying fact. You work and move, this role for you. and then you get more higher roles, additional higher roles based on that experience. And that experience is the experience. Nobody can challenge it. That experience, that experience involves your responsibility, your obligation, your accountability, your performance, and you can say your achievement. That role is very different and unique for everyone. There's no uniformity in that. There may be uniformity, but depending upon opportunities. If you are in designs, you can say there may be uniformity in your approach. But if you are not in designs, you are in execution or prosecution or field, you may have a different type of experience. But that is real education because you made mistakes, you slept or you worked. It depends on that. If you slept, then you won't learn anything. You had been lazy, or you have been, in different mode of enjoying life, not to do, learn something, or you are serious. You did a lot in that. It depends on that. Sometimes you are serious, sometimes you are not serious. Sometimes you are family oriented, sometimes you are not. All this depends upon that. So I now move on to practical aspect of this talk. Yesterday or before that, I concentrated on soil engineering. And soil engineering I'm talking because I consider soil is a preliminary requirement that engineers should have. You may be electrical engineer, you may be mechanical engineer, you may be civil engineer, you may be architect, whatever you are. Your basic requirement is that you are going to work on earth. First of all, you are not going to work in space. You are going to work, not going to work on moon. You are going to work on earth. Means you have to deal with ground. You have to deal with ground contents. You have to deal with internal stress instead of maybe 5 meters, 10 meters, 20 meters, 30 meters, depending upon what you are doing. You may be doing metro work where it's maybe 30, 40, 50 meters down you have to go, or you may work in some buildings which may go to 10 meters down, 20 meters down, depending on basements or something, or you may have nothing else. You are considering water resources, where just complete whole world of water resources is different, or you can say environmental engineering, where you can say it's all different. It depends upon your field of experience, your requirement, what you learn, how you learn means. That's where, but soil is there. You can't avoid soil. You can't avoid soil. Again, I'm saying soil is material number one, which you have to use, you have to deal with, you have to take. This material is existing there. You are not bringing it directly. This exists. You have to understand what is this existence. You have to understand because you are going to add to that much more expensive material forever. Soil is forever. Just like you are going to do something, soil is forever. It may be having more duration of time than your material in. Concrete may work for you 100 years, 50 years, 200 years, but soil is always there, has been there, shall be there. So I can say it's different material, difference. Yeah, a difference of understanding. People do not value and some value, and of course it's natural work on this. Agencies of nature have worked on soil. Agencies like this, it's rain, it's thunderstorm, or it's air, or it's whatever you can say. Natural agencies work on soil. Keep working on soil every day, every moment, and soil changes its conduct, its behavior, its densities, its properties, and depends on what type of soil you build with. So there is no perfect understanding of soil in any way. Soil is soil. It's difficult. Just like we have to take factor of safety, we apply factor of safety in all our subjects, all our designs everywhere. We have to take that point here as well. We have to consider that point here as well because uniformity must be there. I can't say something else about this. I talked to you about soil stabilization last time, and I continue with that until I finish that. I also put one file again. I am reminding. I recorded one video yesterday night on 28th July 2020. That is screen share screen, a facility in Facebook share a screen, but that doesn't continue. There's a problem in share a screen that if you want to share a screen, practically saying you have to share only that screen, and once you stop share, it stops recording, it stops picture, it stops camera. So I cannot continue in that one video all files. So what I thought to record them separately, that files which I get to share with you, so that you can see that file in that record that video, and then you can see this video reference of all those share screen I put in this URL of you can see that on my video desktop that this topic as well as you can say screen share of that video is there. I cannot show you that file directly because first of all I don't have projector here, and I use whatever facilities are available, and I think you have to have some inconvenience on that account, that you have to go to that video first and view that, and then you have to see this file or refer to this talk. This file means I can't help that way. It's like that. So some you have to do some work on that. Now, as we discussed yesterday, this is here. We talked of electrical stabilization and 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 of course thermal stabilization. These were these we talked. This is very brief here in this book because this is a very old book, but I am using it for reference. But at the same time, as searching from internet various files, and I put one file there that's regarding thermal conductivity. I'm going to discuss with you. And this electrical stabilization is very small piece here. It doesn't matter because there's a formula here and some formula there, and temperature relation is there, and you can say then chemical stabilization we did that, and so we will fix this, and then and before going to that file, I say chemical stabilization is also which says that I think this is last one in that. But let me see what chemical stabilization says for your information only. Because once I start that file, I'll be lost in that one. So, thus we talked electrical stabilization. We discussed about velocity of flow, velocity of flow in that, and that was velocity of electrical flow. And that was then the thermal stabilization, the temperature relation to swell index, etc. was shown. Now its chemical stabilization says there are a number of chemicals which are used as primary additives for soil stabilization. Some of them are described below. This is stabilization with calcium and sodium chlorides. Another one is lignin and chrome and and as waterproofers, and then the sodium silicate and waterproofers. There's natural and synthetic polymers, and then there's some I think examples of natural resins and synthetic resins explanations, and so I'll just continue with the small one, that stabilization with calcium and sodium chloride. This is sodium chloride, you know very well. This is common salt you eat every day, and it's calcium and sodium chloride. Reaction of chloride and soil takes effect. It takes places and changes soil properties. Medium of reaction in soil water. Use of chlorides decreases ratio, I'm sorry, rate of evaporation of soil. Use of chlorides decreases rate of evaporation of soil water and lowers freezing point of soil water. A property of chlorides that helps in reducing rate of evaporation is that of increasing surface tension of water. Calcium chloride, sorry, admixture of salt and calcium chloride bring change in plastic properties of soil. Though the change is very small, chloride increases compacted soils density over that of natural compacted soil. So this chloride does that increases density of compacted soil, and calcium chloride being used as a stabilizing agent as well as as a dust palliative, especially in case of soil aggregate mixtures with low soil binder content. Great advantage will relies from calculates to reduce the rate of evaporation of moisture from a me- mechanical stabilized soil during construction. Then lignin and chrome lignin obtained is obtained during manufacture of paper. That's LIGNIN. Lignin and chrome lignin. Lignin is obtained during manufacture of paper from wood as byproduct. From wood we receive paper from wood, tree wood. As byproduct we get lignin, and lignin both in powder form and in form of sulfite liquid has been used as an additive to soil. A concentrated solution partly neutralized the calcium bases known as lignosol. Lignosol, lignosol has been used in Canada for treatment of pavement and railway track foundation. Lignin is soluble in water, hence sterilization effects are not permanent. Effects of lignin on properties of soil depend on form of lignin used and nature of soil treated. Then sodium silicate. Sodium silicate has been used successfully with some amount of calcium chloride for stabilization of soil. Its use in deep foundations is more encouraging, and sodium silicate in this type of soil stabilization sodium silicate and a salt is injected into soil, which forms a gel. Gel imparts cementing actions to soil. This type of stabilization is only restricted to sandy soil, which facilitates injection. While silicate injection is widely used both to im- impermeability both to impermeabilize, as we say, permeability, impermeabilize soils and to impart their strength. There is doubt about permanence of silicate stabilization, especially when treated soil is exposed to air or to basic groundwater. Waterproofers, various chemicals are available for stabilization, which, which impart water retarding, retarding characteristics in soil, and so that they become hydrophobic. They are, what it says, various chemicals are available for stabilization, which impart water, water retarding characteristics to soil. so that they become they become hydrophobic. They are generally used in very small quantities, namely half percent by weight. This requires thorough mixing. Use of these chemicals is restricted to isolated isolated cases and special conditions only. This is a costly method of stabilization. This follows its part two. Two parts should be noted about it. Then continue on this. I will say here that waterproofer now waterproofer. You know waterproofs to use various chemicals various chemicals are available for for stabilization which impart water retarding characteristics to soil so that they become hydrophobic. They are generally used in very small equilibrium quantities, namely 0.5% by weight. This requires thorough mixing. Use of these chemicals is restricted to isolated cases and special conditions only. This is a costly method of stabilization, and following two points should be noted about this, and which are waterproofers have no beneficial effects on soil. Waterproofers have no Waterproofers have no beneficial effects on soil, treated and cured by, but not subjected to water. In such cases, waterproofers may even lower actual strength. Waterproofers reduce water absorption, and thus soil strength is not decreased in contact with water. It says waterproofers reduce water absorption, and thus reduce soil strength is not decreased in contact with water. In other words, water proofers impart no strength, but rather help them retain their natural strength in presence of water. Natural and synthetic polymers. Polymers are long-chained molecules. This is chemistry. Polymers are long-chain molecules formed by linking, that is, polymerizing of certain organic chemicals, that is, resins. Resins and synthetic polymer. Resin and synthetic polymer materials have been used for solid stabilization. Chemicals incorporation chemicals incorporation in polymer method of stabilization can be achieved in two ways. In 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 first method, monomer is added. Monomer is monomer is added with catalyst system which and can which which can which can uses poly which causes, I'm sorry, there's some error in this, which causes, I could not read correctly spelling, which causes polymerization. The monomer is added with a catalyst. With a catalyst, monomer is added uh, with a catalyst and a catalyst system which causes polymerization concurrently with reactions between soil and monomer or polymer. In second method, method performed polymer in solid form, a solution or an emulsion. An emulsion is added to soil. Reaction takes effect. Reaction effects between polymer and soil. Following are some of many resins, both natural and synthetic, which are used for soil stabilization. Natural resins and then synthetic resins. Natural resins, we are talking of natural resins. What are natural resins? Let me just a minute. Natural resins, vinyl resin, let us say winsol. Winsol resin, it impacts almost no strength. It imparts almost no strength to soil. It is called winsol, Vinsol. Winsol resin, it imparts almost no strength to soil but waterproofs finer grained soils. It waterproofs finer grained soils. Winsol resin is a dark brown solid material at about 110 to 115 degrees Celsius, having a specific gravity of 1.25. It is manufactured from from resin from resinous residues. Resinous residues obtained after distillation of pine trees. Distillation of pine trees. So from that pine trees, you get this resin, vinyl resin. On addition to a soil, it reacts with certain metal salts. It reacts with certain metal salts and forms insoluble gels which stabilizes soil. Insoluble gels which stabilizes soil. Resin Resin is obtained during steam steam distillation of oleoresins oleoresins from pine trees during temperature extractions. Shellac. So one is resin with natural winsol resin. Then there's resin. Then there is a shellac. Shellac, a sand treated with shellac solution is in alcohol or malaric and provides high strength, you know, but practically all these strengths, all the strength is destroyed by water immersion. Resin, resin stabilizer. 321, there may be something. It's resin derivative which reduces reduces rate and amount of water absorption and finishes sodium ions for ionization. And stabinol, also a resin derivative mixed with Portland cement which water proofs coastal soils. So there are some reasons, there may be more, it's not given, it's an old book, so we may get something from somewhere else in search. Other is synthetic resin. So previous was natural resins. Now synthetic resin is polyvinyl alcohol, PVA. It forms tough, flexible film when evaporated from aqueous solutions. Polyvinyl acetate. So one was polyvinyl alcohol, PVA, and its stuff from stuff flexible film when evaporated from aqueous solutions, and other one is polyvinyl acetate, which imparts very high strength to sand, but all this strength is destroyed by water immersion. Then aniline furfural aniline furfural. It water it waterproofs and imparts strength to soil. Then urea furfural and phenol furfural resins. Then phenol formaldehyde combinations and urea formaldehyde resins. Then calcium sulfamate formaldehyde resin, and you know then calcium sulfamate formaldehyde resins, and methyl methyl methylol resin areas US and aramines. So these are only few reasons we have here in this book, but this doesn't mean there is nothing else. So I just try to share with you chemical stabilization, and we have gone through electrical. I'll discuss electrical thermal reservation now. After now, bituminous we already discussed, the membrane we have discussed. So and then we'll take up your site investigation and subsoil exploration. Little detailed talk how we handle that and in field here. That is, and we'll say. So I now we have now go to uh, again to our filing, and this we will discuss. And of course, I have to go for 1 minute for my something. Let me go and see. I come back about this point, this material I discussed with you about soil stabilization. This file I'm going to discuss is now, which is a very important file. I always says affects thermal stabilization, soil stabilization, web. This file I'm going to affect open this. This will be very useful file. I yesterday discussed with this. Again, I'll discuss with this. There are some pages on that. And it is title of this file is very good one, and actually that is actually I may not say title, but that is very good in the sense that it it does something for us, and is it's this is don't gas Malaysia. Don't gas Malaysia. It's very good to know. It's actually uh, this is for thermal resistivity. That what we discussed yesterday. I'll first brief that one, and we'll move on that forward. And I think it's best one. Let's now. It's about 1 hour and 27 minutes. But I have to talk about this file. Maybe it takes 1.5 hour more. Then I'll jump on to a discussion in general on this, and then contracts or soil exploration, let us say, which one can happen. Just a minute, I'll be back in 1 minute. Sorry for that. I have moved 1 minute and I'll come back. Sorry, back you. Sorry for this. Back you with you and come on. Sorry, this was necessary for birds. Uh, it's daily routine just to feed them. That's all. Nothing very specific. There was no current today. Around 12, I got up at 1. I could not sleep further. The light was back about 1:30. Now channel back here to system and with system I can say I'm going again to talk of the file we discussed yesterday about thermal resistance, soil thermal resistance and electrical resistance. We discussed so many files for various items. We have discussed stone. We can say what we have discussed. Let me see what we have discussed. We discussed so many files and we discussed in soil. That was you can say in my soil directory here. We discussed the stone columns method in geoengineering projects and we discussed granulated blast furnace slag in engineering behavior of stabilized soft soil, and then we also discussed the same and ground soil resistivity, soil stabilization, bitumen, and we discuss control stiffness, and that is ground improvement services, ground developments, and also ground improvement, ground developments with, and what is soil resistivity and definition, measurement of soil resistivity, and also hydraulically bound materials, HBM and cement bound granular materials. We discussed also we say cement stabilization and modification, ground developments, and of course vibro stone columns and then vibro stone columns ground development, stone columns, and now we are on we are on we are on soil thermal resistivity that we are discussing with an important file, important talk for everyone, for civil engineers, for mechanical engineers, for electrical engineers, for architects, and for contractors, for designers, for students of engineering, and for engineers. In general, this this is thermal. So this is don't guess and measure. Beautiful statement here in beginning. And I talked yesterday about this on 28th July video. This is why it says heat transfer capability to throw a substance by conductors, thermal resistivity referred to as thermal resistivity is referred to as RHO. This is symbolic form referral of thermal resistivity. You can say in this file thermal resistivity is referred to RHO. Then we say we say that we talked of theory and you know theory says never use standard values, understand water content, and density affects RHO. RHO must be measured, consider site specific variables. This is theory, and measure is two ways to test. Create a dry out curve and things to keep in mind, then reporting RHO and standards, then studies, I mean to say studies, and that study is wind farms, data centers, and public utilities, underwater cables, and references. This is contents of this file. In this preface, as we did yesterday, again refresher is better sometimes to understand more than we could talk yesterday, because yesterday I was not having that file on video on Facebook. Now I have put that file in video form on Facebook, and that uniform resource locator is given on text of this video. I go to text one. First one is URL, is title of this video, and also we can say you have done screen share references there, screen share URL of videos there, which you can, if you want to see this file, you can. My voice is with that clubbed, and you can listen to me small brief only, not very much, about 11 minutes. That is, I did not make it, but other videos regarding soil which I'm going to present to you maybe after few days, and those would be soil reports that will be in descriptive form, so that if twice or once or thrice we speak that, we may learn more than we could. So it says it is reciprocal. Now what it says, electrical flowing, electricity flowing in a conductor, electricity flowing in a conductor generates heat. We know that electricity flowing in a conductor generates heat. Resistance to heat, resistance to heat, resistance to heat flow between between cable between cable and ambient environment causes to cable temperature rise. We know that. You know, because of heat, because of thermal engineering energy flowing through cable, temperature of that cable shall certainly rise. This is understood. There's nothing very unspecific in that. Hmm. Cable temperature rise, and cables are buried, when cables are buried, soil forms, soil forms part of thermal resistance. When cables are buried, no, soil forms part of thermal resistance, and 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 thus soil thermal soil thermal properties become an important part of cable design. Is what it says. It's very small para, but it carries big meaning, vast meaning for cable designs, which electrical engineers must concentrate. They do it. They are talking as interactive, as interdisciplinary discussion, and they must they must own this understanding. Again, I say electricity flowing through a conductor generates heat, and resistance to heat flow between cable and ambient environment causes cable temperature rise. When cables are Buried, when cables are buried, soil forms part of thermal resistance. Soil forms part of thermal resistances, and thus soil thermal properties become an important part of cable design. Now it also says in its reciprocal of thermal conductivity. That's right. This is resistance. Conductivity and resistance are reciprocal to each other. It's reciprocal of thermal conductivity in buried cable applications. Soil thermal resistivity is an essential factor in in you know in say Neher McGrath calculations, which which allow engineers to predict predict uh, temperature of buried cables and determine cable ampacity ratings. Cable ampacity means ampere rating, which ampere cable should be. Now, thermal resistivity is often reported in different measurement units. Different measurement units. Internationally, it is reported in SI units, that's the standard international units, as K degree degree Kelvin meter per watt degrees, that is, and Kelvin meter per watt. In 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 United States, it is more commonly reported as a degree C centimeter per watt, degrees Celsius centimeter per watt. Now, even in well-designed systems, even in well-designed system, soil may account for half of total thermal resistance. Even in well-designed system, soil may account for half of total thermal resistance. Engineers need treat soil thermal resistivity with as much respect as they do cables and ducts. Thermal one minute, please. Thermal resistivity, or RHO, we say this is a representation of thermal resistivity. This RHO is defined in National Electrical Code, that is 2014, as heat transfer capability, though heat transfer capability through a substance by conduction. You know, heat transfer capability through a substance by conduction. Now you have theory. It's theory, and this is page 4 of 29. What it says in its index, there are few indexes here. It says never use standard values, and this is page 9, I think. Look at variables, page 11, what to learn from models 12, and understand water content, this 14, water content in field. 15 and critical water content 16. Then density affects HRO. I'm sorry, RHOs 19 and grading counts 20. RHO must be measured 22 and instrumentation is 22. Lab lab services 22. Consider site specific variables 24. Unique situation 24. Watch surface 24 and consider engineered backfill material 25. Hot spots 25. So it is page now 529 and this is never use this is never use standard values, never use standard values. This is represented by T1. Let us see what does it mean T1. Never use standard values. In February 1998, a series of four power cable in 1998 February, a series of four power cable failure blacked out New Zealand's most important commercial district for nearly 5 weeks. Official report cites, now this what actually it is, official report cites insufficient appreciation of importance of soil conditions, says insufficient appreciation of importance of soil conditions as primary cause of crisis. Failure while spectacular, that failure while spectacular is far from only one. Power engineer Keith Lane always educates clients about importance of assessing thermal RHO. We tell them this is a real issue. If you don't account for this condition, you shall have a failure. This says here on title specific the thermal resistance is a real thing. Wow. Now thermal properties, let's say these are given in some sketch form with rectangles and you know and what you call them in columns we say chamfer, yes chamfer, and this is squares at 45 degrees, squares drawn at 45 degrees, and middle square is complete square, while four surrounding squares with chamfered on edge corners. These and indicate certain, you know, certain properties, that is thermal properties, and it is about this. And in between there are in full corner, sorry, central square having lines extended to between parallels of both both chamfered squares, plus minus multiplications and divisions. Let us see what does it mean. Means volumetric heat capacity. First is volumetric heat capacity, and it's mj over m cube k, small m cube k. You'll see what is that volumetric heat capacity. Then other side is density, that is gram per centimeter cube. Mj is joule. I think J stands for joule. Volumetric heat capacity, maybe megajoules, probably can't say. Mj and m cube, and that is Kelvin K. mj is divided by n cube Kelvin, and that is volumetric heat capacity, and density is gram per centimeter cube. And then thermal resistivity is C as degree Celsius, centimeter per watt, degree Celsius, centimeter per volt is thermal resistivity, and thermal conductivity is watt per meter cube. These are four units, one for volumetric heat capacity, that is mj over n cube Kelvin, and one is density gram per centimeter cube, and thermal resistivity degree Celsius centimeter over watt, and thermal conductivity watt over mk, that is heat capacity unit related one. We go on to next page and look at variables now. Now there is a photograph on this, says 40 years thermal research, and shows thermal resistivity of porous materials like soil, rock, and concrete are not constants. That's true. Thermal resistance of porous materials like soil is a porous for them, yes, and rock and concrete itself is porous, are not constants, and there is no typical value for 90% of soil types. Soils and rock RHO values actually vary from 10 to 1000 degrees Celsius centimeter per watt, and resistivity changes with density, water content, temperature, and soil composition. These are extracts what they understand, and again says thermal research shows this, you can say extracts from research, blues from research, you may say, you can say research teach them this, that number one, thermal resistivity RHO of porous materials like soil, like rock and concrete are not constant, varying. Certainly, there's no typical value for 90% of soil types. This means 90%, according to their understanding, 90% soils in whole world are not typical as far as thermal resistivity, or you can say RHO, is related to our concern. Soil and rock RHO, soil and rock RHO values actually vary from 10 to 1000 degree Celsius centimeter per watt. Relative resistivity changes with density. Resistivity changes with density, water content, temperature, and soil composition. Resistivity changes with density, water content, temperature, and composition. So there are 4 points. One is density, other is water content, one is temperature, and other is soil composition. So we can say thermal resistivity RHO depends on point number one, density of soil, and water contents of soil, two, and three, temperature at the soil, or what temperature at that time, and soil composition or constituents of soil. Now look at these variables now. These are all variables. With variable that affect thermal resistivity RHO in soils and other porous materials include density, water content, temperature, and compaction. So these constitute four variables. Now, you can find mathematical models for making this computation in several scientific publications, including Introduction to Thermal Properties of Soil, Devers 1963, and Environmental Environmental Biophysics, Campbell and Norman 1998. These models are based on dielectric dielectric mixing models and test overall resistivity as a weighted parallel combination of constituent resistivities. We use these methods to calculate how thermal resistivity of soil varies with changes in water, changes in water content, composition, density, and temperature. Result of these computations are shown in figure 2, 4 and 5. Alright, so table 1 here shows thermal properties of thermal properties of elements in typical soil. These elements normally occur as mixtures on soil. These elements normally occur as mixtures in soil. Thermal resistivity RHO of mixture is quite difficult to compute since it depends not only on thermal resistivities of components but also on their geometric arrangement. Now, table 1, thermal properties of common salt, common soil, I'm sorry. They due to very small font, I can't read that very clearly. Thermal properties of common soil constituents adopted from Compel Norman 1998. This is one table I discuss, and then there are figures 2, 4, and 5 that we discuss. So, this is table 1 I'm discussing. You can see this table at bottom right corner, bottom right of page 629, 6 oblique 29 of that file I put on that video. This page, now I discussed it. I can, no problem. I think I should take some more water, just lubricate. Right. No, it's now about 5:14. Can say about 2 hours must be. Now I can say now we go further. So in this table, which I say table 1, You can see in that file, I'm just referring to you here. I will not show any photo this time. There are 5 columns in that. Number, not number, but there are 5 columns, and in that, and there are not numbering, but there are one, two, three, 4, 5, 6, 7 rows. Lines are shown. What says in row one top? What's given is nothing in name. In one is name of these soils is given, and in other columns four. Column four. This is one says density of this material, that is gram per centimeter cube. Then thermal conductivity, that is W per meter watt per meter Kelvin. So remember thermal conductivity, not resistivity. And then resistivity, thermal resistivity is, C degree Celsius centimeter per watt. Volume heat capacity, this mj per meter cube Kelvin, same units we got there from that square, corner square, and up square, four you know, chamfered square, four chamfered squares. Now, first material is quartz, other material is soil minerals, and then granite, orange organic matter, water, ice, and air. So quartz, soil minerals, granite, and organic matter, water, and ice, air. These are there. These are there. Now I'll speak these numbers here, which is one number. First will be density, then thermal conductivity, and then thermal resistivity and heat capacity involved. Quartz density, I will not see units, units to take yourself. Density 2.66 and thermal conductivity 8.8, thermal resistivity 11, and volume heat capacity, that is 2.13, volumetric heat capacity. Soil minerals density 2.65 and thermal conductivity 2.5, is less than quartz, and thermal resistivity is 40. Thermal resistivity is 40 and heat capacity is 2.13. And then soil minerals density 2 points. I'm sorry, is granite. Soil minerals are from granite. Density is 2.64. Thermal conductivity is 3. Thermal resistivity is 33, and wall heat capacity is 2.16. And then organic matter, and this is density is 1.3. You can see it's too small, nearly half or less in comparison to quartz, soil minerals, and granite. Organic matter is 1.39. Thermal conductivity is 0.25, too small, and thermal resistivity is 400. Big. Organic matter, thermal resistivity is 400, and thermal conductivity is 2.5. So here's the point of thermal resistivity is 400. And water density is 1, and say thermal conductivity is 0.58, and thermal resistivity is 172. So it is lesser than organic matter but greater than except air all others. And water is 172 and volume heat capacity is 2 point sorry 4.18. Ice ice density is 0.92, means less 8% less than water. I think because of volume expansion it happens, and density is reduced because water when frozen in ice maybe it expands. Then thermal conductivity is 2.5 of ice and thermal resistivity is 40 and wall heat capacity is 2.1. Air, air in soil, that is density is 0.0012 gram per cent cube. You say 0.00012. So it's very small, you can say it is 0.12, 0.012% centimeter cube. Well, 0.0012 gram per centimeter cube. Then you say, can say, if you take into meter cube to multiplied by 100 and 104 zeros, and if you put 4 zeros, then we'll get all this away, and you get, I think, 10012 into 1000. Keep remove this 1004 zeros here. You keep 4 zeros here, and after 4 decimals, so you get 12. Right? Then thermal conductivity is 0.026. Very, very small. Very small. No, it is thermal conductivity by air is very small. Thermal resistance is thermal resistance is 3,846. You know, if your soil is having air voids, then you know it's not well compacted. This means, and it's not well compacted means this porous and much many volumes in voids in air or the voids with air resistivity is 38446 degrees Celsius centimeter per watt, and then volumetric heat capacity is 0.0012. You know these variations of all means you can say organic material is powerful in resistivity, and this is 400 means much more than everything else, and air on top in resistivity, and there is volumetric heat capacity. There's no major difference except this water, and of course you can say that all that are different now. What to learn from models? You have to see that point. What to learn from models? Page 7029 of this file. No, just stretching my body because I want to close yawning. Sorry, gentlemen, I had to do that. Now, well, let's see. Sorry. Now, what to learn from these models that are quantity? Getting always sitting on space. It doesn't go even with his hands. See, These days I'm not walking because of possible availability of carbon droplets in air, and people are not very serious on the streets and on roads. And I don't want to face danger of these droplets. People spit and they don't care. People are not civilized in a way they should be. So I've stopped walking for a few days until I think I'm safe. Well, what to learn from models it is, let us see. Says organized in figure 1 are five constituents that are important in determining thermal resistivity. We did that. Figure 1 we have seen. Figure 1 that is also here. Figure 1, let us see. Thermal thermal resistance, resistance, thermal resistance, very small is thermal resistivity. Thermal resistivity is of common soil constituents, constitution, common soil, maybe constitution, it's written in constituents. Well, that's whatever it is now. This is a figure here. This is shown in half circle, then another curve parallel to that, and then there's cut, and also another cut and cut. And it's giving properties as it says within this diagram. There are two, that's for quartz and for other soil minerals, and thermal resistivity is degrees Celsius, centimeter per watt. Arrow is shown this way, so it indicates these five points of that is number one quartz and other soil minerals, water, organic matter, and air. This is in diagrammatic form which we learned there in some other forms. So this is 11 for quartz, that is thermal resistivity, 11 for quartz, and let us see that figure which is studied. Yeah, table that was there on the previous page, and it says that thermal resistivity, it was quartz 11, and then so many one there, but here in this in this quartz that's 11, and then it is it's, uh, it's other soil minerals. It's soil minerals, and that's 40. Then water 172, and organic matter is 400, and air is 3846. There are 5 points, 5 systems, 5 metals here which are being indicated by. Now, in this, it's about a text here says that without knowing anything, without knowing anything about weighing factors, weighing factors of these, in an actual soil or till material 4, then should be clear. Just like dry my no, just don't mind please. I'm dry my list. It's very much in sweating. Let me dry my list. Soil is not too easy if we do not try to understand it. If you do not understand soil clearly, explicitly, we will have defects in our knowledge. It would be incomplete knowledge. Engineer education should be that strong. Right? It's true that it is. I'm feeling within my shirt because it's difficult to sit and talk if your waist is sticky or moisture, and it's 29 degrees, 30 degrees currently. Come on, do it. 1 minute more. Something is better, I think. Maybe for two minutes, maybe half an hour, I begin. Okay, uh, it will continue later, no problem. So here I say, now air is bad, it says 01. Air is bad. In order to achieve acceptably low thermal resistivity, fill must be tightly packed. You notice what does it mean? It says air is bad for resistivity, thermal resistivity. Yes, it is bad because it's having 4,800, what you see that figure, 3,846 value of air, that is 3,000, 8,400 something, and that is, degrees Celsius centimeter per watt. So must be, you say, air is bad. But bad from what point of view? Bad from thermal resistive point of view. Otherwise, it's for us. So air is bad, we say, because its thermal resistivity is too big, 3846. Too big. 3,000, 3.846, 3.846. So it must be well packed. This means it must be compacted very well so that we can reduce voids. Because air is always available in voids. More voids means more air. So we have to compact it professionally so that as much as air we can. Then next point is if you do not compact it, it won't be dense. And if it's not dense, it won't have strength. It won't have the strength means it will have weakness as foundation support. So compaction as much as can be done to soil. Let's say now it was air now says two. This says organic matter, no matter how wet, shall still be, shall still have a very high resistivity, very high resistivity. So we say that is after air, it is organic matter, no matter how wet it is, still have a very high resistivity because of 400 value rather than you can say about one tenth, say approximately of air. But remember, this is very good conductor. Very good. Now we have mm, we have here replacing replacing with replacing air with water and helps. So let's move further. Replacing air with with water helps for what? Replacing air with water helps, but water alone is still not. So we say replacing air with water alone is still not a very good conductor. And then fill materials high in says fill material high in quartz will have lowest resistivity side side is can't see very difficult. See, you don't feel that font is like that. Maybe fill materials high in quartz. This will have to have impact master. Now we go to it's just a talk here. We have here, it's difficult to really read this. My God, water content, water content, and I think load letter. Water content and thermal resistivity. One abscissa line is water content in percentage, and ordinate is resistivity. This is combination here. It's difficult. I will describe my eyes certainly. Let's close window. Let me close window. Now this graphic representation is the graph between water contents and resistivity. In this graph, you can see in this file, page 7 of 29, there's a graph which is showing three, showing three. So this figure 2 actually is figure 2 is graph. It's mentioned here figure 2 in arrow. So water content meter cube, water content meter cube per meter square. This is now this shows uh, water content from 0 to 0.5 and think at 0, 0.1, 0.2, 0.3, 0.4, 0.5. In this graph, 0 to 0.5 at frequency of zero point 0.1, 0.1, 0.2, 0.3, 0.4, 0.5, and then you can say resistivity from 0 at interval of 100 up to 700, 0, 100, 200, 300, 400, 500, 600, 700, and this is thermal resistivity, and you can read yourself later on. Now, if you graph out that, there are three curves drawn on this, depending on tested values of resistivity. One is lowest one, that is red colored. That's for quartz sand. There's another one about this, and that's for blue color. That's blue color, It's loam probably, and if you see highest one, that is that is quartz sand. In this, you can say I explained to you. You can see yourself as well. These three curves are chained together at various points. It's no use to give values because I don't have exact values, but three curves are there, and lowest is lowest is red one, which is for quartz, which indicates that whatever moisture content within this range, this resistivity is lowest one. 500 in this case is maximum shown by this. So 500, and can say I show this is and maximum 500 in this curve, and in blue one, which is less for one, which is less for and this is from say 500 something to down to same similarly down this this much. And then there's another one that's blue one, no sorry blue one, a violet type you can say, uh, or red color. This organic material you may say, organic, and it's higher than all other. In this, in this 0% here, if you see value of resistivity, it's by for quartz it's 500 approximately. Then for loam, that's blue color, it's somewhere 530 around, and then go to other ones higher ones, much more three. So we go now to understand this curve. Because fast reading is no meaning if we don't go to technical details. I think it's dehydration. There is nothing in zero for that curve, that organic curve. There's nothing in that. If you go further to point, you know, point 0.002, you'll find that um, there's a point for red in this quartz stand, and that lies around 450, and then there's 500 for other one, that's for loam. There's nothing in for other one, the third one, and that is organic. In organic, one reading starts at about point 0.08 1.08, 0.8. Okay, point 0.8 is that, I'm sorry, 0.08, 0.08. The white moisture is 0.08, the content is 0.08. When it's 0.08 ratio of water content, we get, it's organic 700. So we can say, know, higher resistivity is in, of this organic soil. If you see, if you go down to water contents 0.10, zero point 0.1, this quartz is having 100, while loam is loam is 200, and your this uh, organic is having at point 0.1, 550. So in all these three cases, there's a difference. Resistivity is lowest in case of quartz and it's highest in case of organic. In between, nearer to quartz, much nearer to quartz, you can say not much difference actually is quartz, is loam, a difference of few, say 500 to 550 here, and somewhere 450 to 500, and somewhere it's just that content of point zero 0.02. Quartz and loam are near to each other, not touching anyhow whatsoever to each other. And at end, if you say point 0.5, that is water content, that is water content meter meter cube per meter square. It's zero point 0.5, and at zero point 0.5, your your you know quartz is say 50. But if you go and see above, that is organic, it's having much difference. At I said, at zero point 0.1, it is it's 550, and at at zero point 0.2 it is little less than 400, and at zero point 0.3 it's little above 300, and at zero point 0.4 it's little less than 300, or you may say 275, or then at point 0.5, this is 200, maybe 25. So these three variations we have seen on these curves of metals, quartz, loam, and organic. We have to understand this way. Now what it says, we have to say also. Figure 2 we have done. Soil is not difficult to understand if you just closely study this. Because there are no many formulas involved, I think for long. Okay. So we now finish this figure 2, and there is a noting on this figure 2, and this noting is resistivity of wet organic soil. Resistivity of wet organic soil. This is though better than when dry, better than when dry is still much too high to provide reasonable heat dissipation for buried cable. This deep dissipation of buried cable. So this is regarding organic. Now what in general it means, let us see. I'm doing this right now. So much I think heat impact on my waist. So, this morning time disposition, I take many times bath when it happens. In general, thermal resistivity of a mixture, in general, thermal resistivity of a mixture is strongly influenced by component with highest resistivity. In general, thermal resistivity of a mixture is strongly influenced by, by component with highest resistivity. Dry quartz sand and dry loam soil have comparable resistivities as we discussed. Even though resistivity of minerals differ by a factor of 3 a stable 1. Now, as limiting resistivity, limiting resistivity other. So, in general, thermal resistivity of mixture is strongly influenced by component with highest resistivity. Dry quartz sand, dry quartz sand and dry loam soil have comparable resistances, even though resistivity of minerals differ by a factor of 3, as limiting resistivity to be to become as limiting resistivity becomes differences smaller differences in components I think without shirt, but doesn't look nice, you know. You see, sitting without shirt. I'm not sadhu to sit without shirt. It's nonsense. What to do? Humidity is a problem, always a problem here. You know. Now, I say dry quartz sand and dry loam soils have comparable resistivities, and even though resistivity of minerals differ by a factor of 3 physics table 1, limiting resistivity becomes smaller. As limiting resistivity becomes smaller, differences in resistivities of other components have a large effect. For example, dry quartz and dry quartz and you see loam differ in resistivity, but the in resistivity but differ in resistivity, but about 10%. As 10%, while water saturated quartz sand uh, has about half resistivity of saturated. Figure 2, now we are going. Sand is about half resistivity saturated from figure 2. Now we talk of figure 2. We have talked already in this graphics. I explained to you that is figure 2. Now we are going to other one, and that is T2. T2, that is, and it was T1 I think before. T1. Okay, now we go to T1. Never used, so we go to now T2. T2. So understand water content. That's title here. Understand water content. It's very specific file. That's why I'm being a little lazy, so that we have to understand. We don't know something very important. It's soil and it makes understanding by engineers. Yes, I think something more important than your software, structural design software, because you have to design foundation. Without foundation, you cannot finalize your structure. That's the right. Understand water content. It's the important one. Understanding water content. Water content of soil is very important part here. So talking of who's considering no, understand water content. Problem. If I closely, I keep it up, not to be close too much. All right. Oh no. Where are you? Yeah, actually, it was some, I don't know. I just didn't. So what I sent is other one is 2 out of 2 minutes. That's 2 out of 2 minutes. Let's see. Water, understand water content and necessity too. Now it says a quick draining soil, a quick draining soil like coarse sand, quick drain or completely permeable, no problem. Like quick drain soil like coarse sand, and quick drains coarse sand will respond differently to precipitation and fine soil. Right. Quick draining soil like quick sand. Like I'm sorry, quick draining soil like coarse sand. Coarse sand respond differently to precipitation than a fine soil. Fine silt soil, asphalt and concrete, asphalt and concrete. So we are talking of sand which dries very rapidly. Put on this kind of on I can't see it. Put on that first. Let us see who behaves. A quick draining soil, a coarse sand respond differently to precipitation than a fine soil. Asphalt and concrete coverings like roads and sidewalk, we are talking of roads, asphalt road coverings like roads and sidewalks with good drainage system can prevent moisture from reaching soil. Plants can draw moisture out of soil. Plants plants can draw moisture out of soil as horticulture, but only to certain point. And soil below and even slightly above a water table can remain saturated, outpours filled with water, as is displayed in bottom frame of figure 3. Figure 3, and that is figure 3 here. It's given, there are three molecules, air molecules represented here by what? Some air molecules is given by, I think in representation is, what is one represented as a mineral particles, and molecules, I think this is that. Mineral particles, these are mineral particles. And water molecules, these are water. Blue color is water molecule. Pink water molecule, and this blacks, it says particle, mineral particle, and air molecules. Uh, this is written punctually. Okay, so it says we got that figure 3 continuum of mineral, water, and air mixtures uh, relating, relating to hypermeasures defined. So this figure here is shows there are three circles. Higher resistivity is shown plus. There are three circles in that. One is air part, one is water part, and one is mineral part. Say then these are representations, and now if you see water content in field figure 3. Water content in field. Now figure 3 is a graphical representation of different minerals. These circles I'm showing you, blue circles the minerals. This is you can say graphical representation of different minerals, waters and air mixtures that make up a soil. At a static density, soil minerals are constant. It says at a static density, soil minerals are constant. Whereas water and air complete. Whereas water and air complete, you can say water and air complete for same space, compete for same space. Water and air compete for same space. Compete means they want to occupy space. Soil and thermal resistivity changes based on amount of water or air held in soil pores. Now figure 2 shows impact of air and water, impact of air and water ratio on thermal resistivity of three different soils. It's clear that thermal resistivity of soil will vary by a factor of 5 to 10 at water content changes. Since thermal resistivity varies so much with water content, since thermal resistivity varies so much with water content, and water content in soil is so variable due to precipitation, drainage, evapor- evo- evapotranspiration, and moving water tables, it is important to fully understand water content of soil. Hmm. Since thermal resistivity varies so much with water content, thermal resistivity varies so much with water content, and water content in soil is so variable due to precipitation, drainage, evo, evapotranspiration, and moving water tables. It's important to fully understand water content of soil. Now, critical water content. This is page 9 of 29. Critical water content. Minimum water content in root zone of growing plant typically ranges from point or 0.05 meter cube per meter cube. This is minimum water content in root zone of growing plants typically ranges from 0.05 meter cube per meter cube of sand. This means zero point 0.5 I mean to 0.05 meter cube water meter cube, and 1 meter cube is 1000 kilogram, and this is 0.05 meter cube. This is 1/20th of 1000 kilogram. 1/20th. 1/10 is 100, so 200. This is 200 kilogram per meter cube. So this you can say minimum water content in root zone of growing plant typically ranges from 0.05 meter cube per meter cube in sands to 0. 0.1 or 0.15 meter cube per meter cube for finer texture soils. So three times of final textures. 0.05 means three times 0.015. So that's in finer texture soils. So sand is 0.05 meter cube per meter cube, and you can say finer texture, that's like clay or something that way. It's 0.15 three times. These water contents correspond roughly to water contents of threshold. And this figure 2, where resistivity increases rapidly with decreasing water content. This threshold is sometimes called critical water content. That is figure 2. So figure 2, where resistivity increases rapidly with decreasing water content, that threshold is sometimes called critical water concept, water content, and says and and is more closely related to hydraulic properties than to thermal properties of soil. Now, above critical water content, soil acts like a above critical water content, soil acts like a heat pipe. Above water content, above critical water content, soil acts like a heat pipe to rapidly and effectively transport heat through soil pores. Effectively transmission by pores. In this process, evaporates water within pores evaporates on hot side on hot sides and transports the latent heat across pore, then condenses on cool side. So in this process, water within pores evaporates on hot end of side, transports latent heat across pore, then condenses on cool condenses on cool side and flows back across particle is raised, flows back across particle size, particle, So on cold side, you can say it most soil don't dissolve that surface. Particle surfaces to evaporate outside, transports latent heat across pores and condenses on cold side and flows back across because particle surfaces to re-evaporate on hot site in a moist soil at room temperature. 10-20%, 10 to 20% of total total rock. Okay, we forward now like this. Put this fan also on. I'm feeling a lot. So this is process of water that we deal with in this, and it is it goes on to hot side and transport latent heat to cold side and then flows back across particle surfaces to re-evaporate on hot side in a moist soil at room temperature 10 to 20 degrees of total heat. Transport occurs in this way. This phenomenon is strongly, the second one. This phenomenon is where's the other one? Maybe next one. Strongly, yes, strongly temperature dependent, roughly doubling for each 10 degrees temperature rise. I see. Doubly at 10-degree temperature rise. Critical water content point is significant in buried design, cable design because when soil moisture level when soil moisture level around around cable. Okay, so we may say, I'm closing eyes, I think sometime. Critical water content point is significant in buried cable design because where when soil moisture level around cable approaches this point, cable heat would drive moisture away during drying soil. So let us say one was this dependent temperature dependent and doubling for each 10 degrees temperature rise. We will see in graph how it works. In critical water content point is significant in buried cables where buried cables design because when soil soil moisture level around cable approaches as point cable shell cable heat near. Okay. All right, so now we will discuss this in clear terms. It is here graph, and this is which figure it is. This figure four, water content and thermal thermal resistivity of a silt loam and at different temperature. This is what we are going to discuss. Figure 4 and figure 4 water content, and let me just blow it little up. Please, hold on please. Just a minute please. My fan, come on, come here, don't come here. So this graph is between moisture content and resistivity. I'm not sorry. Is this thermal resistivity? Thermal resistivity, and that is in degrees, and that is about here water content. So we are talking of temperature. Is that yes? This temperature is, you see temperature here, and that is there are three temperatures given here. Temperature for temperature for quartz is 50 degrees Celsius. For for loam is 25 degrees Celsius, and for organic is 0 degrees Celsius. What does it say? Temperature. Now we have to understand this point. Water content and thermal resistivity of silt loam of different temperatures. This is graph. Now on abscissa, this is same water content from 0 to 0.5, 0.1, 0.2, 0.3, 0.4, 0.5, and these are having divisions such as this. There are five divisions in 0 to 0.1, so it could be 0 point divided by 20, so 0.00, 0.0, 0.02, 0.04, 0.06, 0.08, and so you can see it's like that. And then we have this thermal resistivity from 0 to 700, but temperatures are low. We are taking 25 degrees Celsius, and your quartz we are taking 50 degrees Celsius. What does it say? That's the point here. If I see that, you see this curve here. If we see curve of curve of quartz, and this is at zero moisture content, water content, resistivity is 500, 500. And if you go to if you go to your water content about point one, point one, says that at point 0.1 water content, its resistance is 105 approximately. 105 at zero point 0.1 water content, and at zero content this is 500 something. You can see difference now at 50 degrees Celsius. If your quartz is at 50 degrees Celsius, this is your resistivity, means 500 there. And if you see at previous graph which was there, which we noted in that graph, I think it was also nearly same, but only off. Point 1 it was 100, point 1, and here at point 1 it is, its point 1 is 100 and 0 point 0 is 500. And if you go to point 2 it is 100, and go to point 3 it is 100, and we go to point 4 it's 100, and if you go to point 5 it's 100. This means up to point 1 and point 0.01, point 110, point 1, and point 0.01, point 0.01. So at, you may say it's like flat line after point 1, 1, or you can say point 12 at 0.12. After that is little equal to 4, so it's little slope, and up to 5 it is not exactly 100, but it is 50 plus, maybe 0.8, that is limited relative thermal resistivity. So it is different. And if you go to your low is same. If you go to your sorry, if you go to low it's 25, while while that other one. So when we are talking of loam here, it starts some similarly at same point. It's all these three are, I know, somewhere coming together, uh, particularly from point 0.2. These are coming too closer to each other, and at point 0.4, approximately 0.4, variation. Now we go to point someone else. Let us now think of this. We have already done this talk. Now, what notes say, what there's one picture here. Uh, This picture क्या कहती है? Let us see this picture. What it says. It's page 9 or 29. There's a photograph. Thermal resistivity.com stability, and it says soil thermal stability is a more accurate model for getting at critical water content. Soil thermal stability soil thermal stability is more accurate model for for getting at critical water content. Soil thermal stability is controlled by systematic coupling of heat, water vapor, and liquid water through transparent through transport of. Really, soil thermal stability is a more accurate model for getting at critical water content. Soil thermal stability is controlled by systematic couplings. Soil couplings. Okay. No, it's not. At critical water content, soil thermal stability is controlled by systematic. Is controlled by. Okay, then we say why you leave this, not don't leave it. Just think on is what's written. Soil thermal stability is controlled by systematic coupling of heat, water vapor, and liquid water through which through through one water through transport of latent liquid and mm, water vapor and liquid water through transparency of latent heat. But why should we know? Says water vapor and liquid water through water water, liquid water through transport of latent heat of vapor lux this distance water is. And transport latent heat by vapor plus Okay, so this note is very important. For more on thermal stability, visit our site. We will not go to visit that site. So it's very important point here. Again, I read this snap. Soil thermal stability is a more accurate model for getting critical water content. Soil thermal stability is controlled by systematic coupling of heat, water, vapor. Coupling of heat, water, vapor, both, and liquid water through transfer of. Then you can say, I stop always here, I do what? By systematic coupling of heat, water, and liquid water through transparent, through transparent of transport, I'm sorry, through transport of latent heat by vapor flux in soil. That is Devrice 1963 tell us and okay, now let us now move to temperature dependent across the year. Temperature dependent, roughly doubling each 10 degrees. That's okay. So this is from there, I think. Okay, from there. Then we can say here's the now the same figure is here. Sure, in figure 4. Temperature does play a role in determining thermal resistivity of water formulation. Temperature does play a role in determining. We have done that. Okay. Now T3 density affects RHO. Density affect RHO, and this is density affect RHO. RHO means thermal resistivity density. Here's a photograph on this pipe laid on panels. This is photoelectrical conduit pipe in trenches, and this is T3 density affects RHO. It's already shown file. I'm just telling you what's that. How much time I have? Let me see how much time I have. It's now 6:46. So Okay, let us see how much I am back. More water today, possibly. Density affects RHO. Now there's a note here over the informative note. Note that green curve in figure 2, 4 and 5 are same plot as they represent same data for a common loam soil. Okay. Now density affects RHO. Density affect RHO. This you can this pipes of electrical duct you can see now it's talking of. Figure 5 shows how important compaction is for achieving acceptably low thermal resistivity in backfill material. How important compaction is for achieving acceptably low thermal resistivity in backfill material. You know what happens in our country? Just fill and go. No compaction, nothing. When it's JCB, fill it and run. Our quality system, great quality system. Value often a value often assumed for thermal resistivity of soil in buried cable calculations is 19 and 90 degrees Celsius centimeter per watt. This is typical density for a field soil that can sustain plant growth is around 1.5 grams per centimeter cube. At this density, even a quartz soil has a resistivity more than four times assumed one. Get that point? Means just compaction has been discussed. No compaction, the density is reduced and value often assumed for thermal resistivity of soil in buried cable calculations 90 is 90 degrees Celsius centimeter per watt. Typical densities for field soil that can sustain. Okay, now it says at this typical density for a field, so that sustained plant growth is around 1.5 gram per centimeter cube. This density even a quartz, quartz. These quartz soil has a resistivity more than more than 1 point more than now. Now we look bulk density and thermal resistivity is for a low lake for a loam soil, and is here a graph which is figure 5. We go through this now. Again, same water content and other one is thermal resistivity, but there are bulk densities. Uh, Come on. Same ISIS, same graph except density difference. Now here we are keeping bulk densities of your quartz 1.59 and for loam 1.33 and for your and what was the name? Uh, yeah, yeah. This organic, organic, yes. It's 1.06. So bulk density of parts is 1.59 and loam is 1.33 and for this is organics, this is 1.06%, and we can see difference is here at zero water resistivity is down to 400 and and resistivity of this loam is 550 and that's of you can say third one is so loam is 700 sorry loam is 550 and what do you call it again I call it this organic is 700 at zero and if you see at point 1 0.1 this quartz is 150 and loam is 200 and your organic is 260 something and if you go to point 2 0.2 this quartz is 100 whereas loam is 120 something and uh, so that's yeah. Similarly, if you see at point 3, this quartz is now 100 and loam is not 100 actually, little 100, lesser than 100, say it is 80 and loam is 110 possibly and 150 is you know, quartz. And if you go down to another one, and if you go, you'll find at point 5 this is about number one is the squats about 50 then it is second one lower and third is okay. Now we come down because there is a density improvement here resistivity is reduced actually resistivity thermal resistivity is reduced when you come out of moisture content zero 0.1 zero point 0.1 up to start at 0 is too high at zero point 0.1 it's low in between is and then this coming flat to that one This is external one. So what it says now, it's another one, and that is grading counts. Grading counts. Let us see what it says. Grading counts. Analysis there's different subject. It's very important. Understand this soil. That's why you know, I decided to complete this first so that I can move on to someone else. It's very important point for solid 342, 657, maybe for about half an hour more for me. 345, no problem. We'll make it over. Let's say grading counts, it is something. Grading counts. What says? Okay. It's worth mentioning. It's worth mentioning. Mhm, mhm. It's worth mentioning that arbitrarily high densities are not attainable just by compaction, uniform sized particles packed to a given maximum density. To attain densities beyond that without crushing particles, smaller particles are added to voids between larger particles. Highest densities are therefore attained by using well-graded materials. And then you go to RHO must be measured. RHO must be measured. This is page 12, instrumentation and thereafter. RHO must be measured. What does it mean? While it's possible to compute thermal resistivity, it's usually easier to directly, measure it directly. Of soil thermal properties should be guided by a standard like ASTM D5334-14, a standard test method for determination of thermal conductivity of soil and soft rock by thermal needle probe procedure. IEE 4421981 Guide to Soil Thermal Resistivity Measurements or Methods. Methods of Soil Analysis. By Soil Science Society of America. Now, measuring thermal resistivity of soil using heated needle technique as suggested in standard mentioned above is straightforward. Adhering to a few measurement tips can ensure you get accurate data. The instrumentation in this is All right. ASTM D5334 suggests a needle probe having a large length to diameter ratio to simulate conditions for an infinitely long, infinitely thin heating source. They are There are two types of heated needle instruments outlined in IEE 4421981. A field thermal, a field thermal needle is approximately 200 centimeter long. 2 meters. This means 200 centimeter long is 2 meter. Mm. And 8 in diameter. IEEE 4421981 suggest suggest a laboratory thermal needle. 100 long and 2.4 in diameter. Terminology of field and laboratory is a little misleading as a small needle can be used. Can be used in field can be used in field. Terminology of field and laboratory is a little misleading as a small needle can be used in field as long as one can access soil. Okay, next to you see, field needle is an acceptable method. It says there's some confusion, no problem. It says as a small needle can be used in field as long as one can access soil of interest. Terminology of field and laboratory is little misleading as a small needle can be used in field as long as one can access soil of interest. Field needle is an acceptable mentioned in appliances. All right, let's move further without any hapki japki. So it says field needle is an acceptable method for measuring soil thermal resistivity where soil of interest can be reached through a test pit or sample boring. If you cannot take other one is field needle is good, you can say, to acceptable match method for measuring soil thermal resistivity where soil of interest can't be reached through a test pit or sample. This is 2 meter long, 2.4 in diameter. Remember, it's no, it's 2 meter long, 8 mm in diameter. I'm sorry. Five field thermal needle is 200 centimeter long and 8 mm diameter. Suggests the laboratory thermal needle is 100 mm long, 2.4 m. Little difference. Laboratory is 100 meter and 2.4. That's more here, 8 mm. 8 mm in diameter, 2 meter long. So both are approximately the same, I think. So field is okay. Right. Okay. Now we move further on to that. Say, so you have two diameters, two types of needles. Field needle is 2 meters 8 mm, while level needle 1 meter 2.4 mm. You just remember this point, and it's good for just to directly take into. You can directly go to visual this in field. The lab services exercise, lab service. Now, one more point here is that. So measuring thermal resistivity in soil using heated needle technique is suggested in standards mentioned above. Okay, that's fine. Now, lab services, there are numerous companies that are willing to do thermal resistivity lab tests and or create thermal tryout curves for information on labs on your area. Say, okay, this is where that commercial leave that. Now, five is consider site specific variables. Site specific variables. This is not bad. It's page 13, 29. Let me put off light. Light. Now, this, I think, I'm also getting interest in this information because this is some practical book, practical page, not just written by some inexperienced person. Consider site specific variables, unique situation, site specific variables. Says powering powering data powering data centers is a unique challenge. Data centers have enormous building footprints with rain drainage systems that move water away from soil under building. If soil is dry to begin with or dries out from cable heat, there is no chance for soil moisture replenishment. Data centers also have large constant power demands coming through high concentrated cable configuration. Applying standard values on this unique situation is a recipe for disaster. Let me repeat. Powering data. Powering data centers is unique challenge. Centers have enormous building footprints. Data centers have enormous building footprints with drainage system that moves water away from soil. Under building. Powering data centers is a unique challenge. Data centers have enormous building footprints with rain drainage system that move water away from soil under building. If soil is dry to begin with or a dries out from cable heat, there is no chance for soil moisture replenishment. Data centers also have large constant power demands coming through highly highly concentrated cable configuration, applying standards values in this unique situation. Now watch surface what it says. Let us see. Also, it says in addition to issues discussed about there's always several site-specific issues that need to be taken into account when designing and implementing underground power cable systems. These include depth of burial, surface conditions, backfill, and surrounding vegetation. Watch surface. One point is watch surface. What's that? Watch surface. Surface conditions shall also surface conditions shall also impact water. Surface conditions shall also impact water and energy exchange between soil and atmosphere, hence thermal environmental environment around cable. It says troposphere surface conditions shall impact water and energy exchange between soil and atmosphere and hence thermal environment around cables. In cities, surface will be more than likely covered by roads, buildings, parks, or gardens. While in rural areas, bare soil or vegetative, vegetative cover will be most common. It's important that surface condition, surface condition and its impact on underlying thermal environment environment be taken into account and spatially change in surface condition if any whatever change in surface condition that could result in unwanted consequences. Add, adding vegetation, for example, could result in significant soil drying with potential consequences as discussed earlier. Now, in this also we see that there is this photograph here which is showing some crawler mounted machine working. Consider engineered backfill material. Now it says consider engineered backfill material. Then hard spots in that, let us say, engineered backfill material. What is that, first of all? Lower dry resistivities, now lower dry resistivities than those shown in figure 2 can be achieved using specially designed backfill materials. For example, one thermally stable backfill can be poured in place and has a dry resistivity of around 75 degrees Celsius centimeter per watt, decreasing to below 50 degrees Celsius centimeter per watt when wet. When native backfill is not suitable, when native backfill is not suitable, thermally enhanced engineered backfill. Okay, now says, for example, one thermally stable backfill can be poured in place and has a dry resistivity of around 75 degrees Celsius centimeter per watt, decreasing to below 50 degrees Celsius centimeter per watt when wet. When native backfill is not suitable, thermally enhanced engineering backfill may be required to ensure adequate thermal conditions. Hard spot, hard spots. Why, yeah, these people don't, they have no sense at all. Yeah, क्या करूं मैं नो पता नहीं कौन सी धुन हो रहा है यार ये. Potential hotspots. Potential hotspots along cable route. Potential hotspots along cable route, such as zones of well drained sandy soil, well drained sandy soils, or vegetated areas that could lead to significant soil drying should receive particular attention to ensure long-term success of any installation. Clay soils in particular can crack on dry. Besides, clay soil in particular can crack on dry, resulting in development of air gaps around cables, and every effort must be made to avoid these situations. It is now measured, measured this. And now it is, this is two ways of to test. Field testing and lab testing. This is page 25, 29 and 30. It's not here anyway. Create a driver curve 20. This is not in this. I can take all that. Measure. Now M1 two ways to test. If you don't account for this condition, you will have a failure, and that's written here. Two ways test M1. Ah, it's M1 means measure. M stands for measure. L then wow. It's L, I think. L, T, was T. That was testing. Okay, testing. T, measure to test. There are two ways to test thermal resistivity of soil. You can either test directly in field or take a soil sample and test in laboratory. Field testing. Field measurements typically don't give you much information. A field measurement in a single snapshot of soil thermal resistivity in time, relying on relying on snapshot of RHO can lead to poor design. Uh, Relying on snapshot of RHO can lead to poor design because thermal resistivity is dependent on soil water content, which is affected by precipitation, drainage, evapotranspiration. Okay, let me see. So it says that thermal resistivity is dependent on soil water content, which is affected by precipitation, drainage, evapotranspiration, and moving water table. These are photos. You see needle. The top is photo where his needle is given. This is photo where we can say just a minute. If you do not account for conditions, you will have a failure. This is written here. And these photos have been here. These photos, if you don't care for, it's written there are two ways. Okay, field testing, field measurements typically don't give you much information. A field measurement is single snap that you have done, and photos top needle is inserted into ground during field testing. And soil sample from field is tested in laboratory. Page 16. It's also 7:25, maybe 10 15 minutes more. Not much, not more than that. I finished this job today. Yes. Okay. Now it says if a client insists on specifying field testing, this is your page 1629. If a client insists on specifying field testing, even after you explain why this is bad idea, make sure to measure thermal resistivity at a depth of buried cable, and make sure that soil temperature is not changing rapidly during measurement. That is, the direct sunlight is not heating soil in bottom of trench. It would also be A good idea to measure soil water content and report that value with thermal resistivity. So it says, don't worry if your client says no, I have to measure in field, measure in field, no problem. But go to cable depth that says, don't just do it random and be aware of sunlight. So let us repeat. If a client insists on specifying field testing even after you explain why this is bad idea, make sure measure thermal resistivity at a depth of buried cable and make sure that soil temperature is not it doesn't change rapidly during field measurement, that is direct sunlight does not heat soil in bottom of trench. It would also be good to measure soil water content and report that value with thermal resistivity lab testing. So it says no matter if you are measuring in field or lab, here are some tips. We'll take these tips later on. First we finish this. Lab testing. Lab testing. Lab testing. Lab environment allows for soil variable manipulation to better represent changing soil characteristics over time. You have read throughout this guide water content and density are critical values in determining thermal resistivity of soil. In laboratory, water content can be manipulated to generate a complete picture of soil's thermal resistivity, typically through creation of a thermal dry-out curve. In lab, different densities can also be established for, for cases where soil be compacted to densities different than natural state. What sampling for lab testing? Be sure to mm, when sampling for lab testing, be sure to consider bulk density by the preserving natural bulk collection of intact cores or specifying bulk density for loose soils. If field soil is to be compacted during cable installation, namely packed to 95% of maximum, maximum, maximum density as determined by. So fintech course on specifying gold density now loose soil. A field soil is the compacted during cable installation, that is namely back to 95% of maximum density as determined by Proctor test. This bulk density should be mimicked during testing. During lab testing, it's also critical to monitor conditions that may affect measurements such as moisture gradient in soil sample, namely dry outside, dry outside, wet inside, and soil cracking during dry down in high clay samples. So it's also critical to monitor conditions that may affect measurements such as moisture gradient in soil samples, dry outside, wet inside, and soil cracking during dry down, high clay sample. So we say cracking. No, we have to be careful of that. Say soil cracking during dry down in high clay samples. Cracking is high clay soil presence problem not just in lab but also to overall installation where cracks can create dangerous air pockets around cable. And it also says one here, no matter if you measure in field or lab, some tips are here. What are those tips? Let us see. Information only. Information not bad. Small needles shall bend, so small needles will bend, so do not force them into soil. Instead, attempt a few insertions to find a site that needle can be completely buried in soil. If necessary, use a pilot pin or drill a pilot hole. Ensure there is good needle to sample contact. If needle if needle feels loose in a pilot, so it's a point, short question back. Ensure that needle to sample contact needle feels loose in a pilot hole. Start over with a new hole or use thermal grease to improve needle to sample contact. Make sure, no, wait a minute, wait a minute, small needles will bend, so do not force them into soil. Okay. Now, allow needle to thermally equilibrate. Allow needle to thermally equilibrate with soil material being measured for small needles. 2 to 5 minutes is usually enough. Make sure sample's temperature is stable. Changing temperatures to other than heating needle can so important that you see. Ah, Changing temperature other than heating needle can throw off calculations. Yes. Make sure sample's temperature is stable. Changing temperature other than heating needle can throw off calculations. Take multiple measurements at different sites. Take multiple measurements at different sites in same soil. A minimum of three readings. A minimum of three readings allow you to compare data to identify bad readings and confirm accuracy of set of readings. So now see, let's now create a dry out curve. Create a dry out curve. Let us see our status 423. Still we have time. Create a dry out curve. Thermal resistivity of a space 17. Thermal resistivity of a soil. Thermal resistivity of a soil depends on its water content, bulk density, temperature, and composition. Size. Thermal resistivity of a soil depends on its water content, bulk density, temperature, and composition. Temperature and composition. For soil in place, composition and density are fixed, and temperature typically varies over a narrow enough range to have only a small effect on thermal resistivity. This is not case if soil freeze during cold months. Main variable for soil in, in, in places, therefore, moisture. Main variable for soil in place is therefore moisture content. Purpose of thermal dry out curve is to represent effect of soil moisture content on thermal resistivity. This section details a simple method for developing a soil thermal dry out curve. Here is this. So some labs take an as received average value to check against the calculated curve. Now creating a dry out curve, the age 18. What says 1, 2, 3, 4, 5, 5. Creating a dry out curve. 01. Prepare a soil sample at least 5 centimeter diameter and 10 centimeter deep, either by coring undisturbed So we have this 5 centimeter diameter intensive heat, either by coring undisturbed soil or recompacting a soil sample to desired density. Saturate this number two. Saturate water by placing it in a pan of water around 9 centimeter deep and allowing it to stand overnight. So saturate sample with water by placing it in a pan of water around 9 centimeter deep, allowing it to stand overnight. Okay, then we can say we saturate that, all right, to our desired density. Then we can say insert thermal needle probe into sample and take a thermal resistivity reading. Weigh sample and record weight into thermal resistivity. Weight and thermal resistivity. Place the sample in 105 degrees Celsius oven to fully dry it. Cool sample to room temperature and take thermal resistivity measurement and weight. Then what? Now, from weigh measurement when wet, this set of measurement is fixed to 2 points on data. Now, from weight, temperature, weigh measurement, compute density and water content when wet. This set of measurement fixes 2 points on diagram curve with direct measurement. You can then interpolate curve between these 2 points using an equation from compute compiler. Okay. So this is now formula here. Again, I'm thinking about this RHO, which is MQW, which is equal to 1 over A plus BO, BQ plus D minus A, 1 minus G, where, where O is theta is volumetric water content, that is MQM, and constant in the equation are determined from measurements D equal 1 over RHO dry, and you can say B equal 2.85 equal to 2.8 rho P or S, and where rho S is M cube N minus Q is solids refraction of solid bodies. Measured bulk density gram per centimeter cube of sample, and rho is where particle density generally assumed to be 2.65 gram per centimeter term in this case. Okay, now this formula we have to see, we'll look into that. It's important to look into this formula because the dry out curve this is. So this A1, this is RHO is equal to 1 over A plus B theta plus D minus A 1 minus G. 0 is volumetric water content, which is meter cube of meter per meter cube, and that's theta. Constant in equation are determined from measurements. D equal to 1 over RHO dry, B equal to this 2.85 is 28.8 pp of PS, and beta and Q contributes solid fraction of soil, and rose is measurable density G per centimeter cube of sample, as well as the particle density generally assumed to be 2.65 gram per centimeter cube, and term G is discussed below. What was a value of 1 when soil is wet, or so from equation 1, and measurement at saturation, and this is A is equal to 1 over RHO minus P to theta, and RHO is thermal conductivity of, of what is soil, wet soil. Function G goes from value of 0 for dry soil. Function of G goes from value of 0 for dry soil or 1 for wet soil. If G is equal to 0, theta is equal to 0. R substituted theta is equal to theta. Or stipulated R is equal to R. Change function G is computed computed from is equal to 1 over 1 plus theta over. Then other is where theta is cutoff water content for liquid return flow in soil in more about critical water content. Functions shown in figure 6. Cutoff water. Cutoff water content can be estimated from clay fractions of sample using equation. equation. Return equal to 0.3073 and C plus 0.03334, and in If heavy, if the clay's clay content is not known, if clay content is not known, can be estimated from soil texture using following table 2. Clay content, of course, that is with a textural class. Clay cutoff water content taken by equations is also shown in table 2. So I think we close this today here to take up next time. It's already 4:38 and it should close it now. It's time to heavy time. I think we should. The units used in equation are mk but multiply by 100 to get degrees Celsius. So this is it. This the equation will review again. And the thing to keep in mind: open drives, air drive. This page 20 will take later on. I'll close this file. Here's what we actually reviewed this file today. Um, I'll close this file now because what we have understood today is that we have gone through the of resistivity, thermal resistivity, very important part, may not be directly important for cylinders, but it is. Certainly, where hundreds of utilities are laid in plants, not directly to buildings, but where plants are concerned, facility plants or big plants are concerned, the many utilities are there. And compaction is a very big factor here. We do not compact well. We do not take it very seriously, and particularly in our country, where it's like zero. We don't care for compaction, and particular, it's not nowhere care for that basically, and that with what happens, very well. It's therefore very important to be clear about this, and I think we should close it now. And this is must do. Thanks very much for all that. I'll take up this issue again. I'll try to post soil reports also on screen share sometimes. I'll do that so that we can continue this subject and soil exploration and also this soil reporting. We take continuation of that. With this, I'll close this. Thanks very much once again. I'll read tomorrow again.